Okay, this is the second lesson of the waves. Okay, now let's quick look at the lesson objectives. First, the vocabularies. What I will teach you. What are the first the vocabularies? Earthquakes. Okay, P waves, S waves, mechanical waves, electromagnetic waves, and what is the relationship between the waves and medium will be taught in this lesson. How do waves transfer energy? Earthquakes send out both type of waves. Primary waves, called P waves, are longitudinal waves. They always arrive first, okay? The secondary waves, called S waves, the transverse waves, they always arrive second. Earthquake actually is the form of wave, which is transferred from one part of the earth to the another. But we know that it doesn't have just one type of the wave. It has two types of the waves. What? Longitudinal waves and transverse waves, both. Okay? Now, why primary waves are called primary? Because it arrives first. It actually gets the distance first than the S waves. It is faster than primary waves, longitudinal waves are faster than S waves, okay, transverse waves. In the earthquake, we are able to see both. In this video, I can explain better. For example, the earthquake is originated from this point, okay? Then the waves are actually gradually spreading around. As you see here, firstly, the longitudinal waves firstly transferred from the origin to the environment. Because the longitudinal wave is the effect of the vibration from one particle to the another, from one atom to another, from one molecule to another. That's why it goes much more faster. The compression and expansion, actually it's called expansion as well as rarefaction. You see the direction of the wave and the direction of the wave motion are in the same direction. And movement of the molecules and movement of the wave in the same direction. That's why it's called P waves. S waves actually, it moves the whole ground up and down. That's why it goes much more slower. Because interaction between the atoms are much more quicker than interaction between the land, the whole mass. That's why transverse waves are much more slower than actually a longitudinal wave. Waves can also be classified by what they are traveling through. Waves that require a medium, such as water waves, are called mechanical waves. Okay, whichever needs the medium, that they are called mechanical wave. For example, water and sound. Both of them are mechanical wave. Why? Sound needs medium like air, like water, like solids. It has to be in the medium to be transferred because it is a vibration. Okay? How about some mechanical waves can travel through more than one medium, water, solid, liquid and gas. For example, sound waves can move through the air, water and solid wall. Mechanical waves cannot travel without a medium. Over here you are able to see the mechanical waves, sound waves, are not able to move from the vacuum to the outside because there is no air inside of the vacuum. That's why the sound is not transferred to outside. If it is fulfilled with the air or water whatsoever, definitely the sound will reach the outside. Okay, how about in the space? Is there any sound? There are many explosions on the sun. Are we able to hear? We are not able to hear anything. Why? Because there is no air, there is no any material in the space to transfer the sound, because the sound is mechanical wave. Here there is a video. He's explaining actually, he's experimenting how sound is affected by the medium. If there is no medium in the one jar, how the sound doesn't come outside. Let's see it.
Wow. That's a huge difference right there. Alright, air is being pulled out. I admit I hadn't actually tried seeing what happens with cotton balls in a vacuum before just now. I don't think it's going to do anything, and it looks like I'm right. They aren't puffing up the way marshmallows do because they aren't holding any air. There's just air in between the fibers. This is looking good. Almost up to a vacuum. We have very little air in there right now. At about 25. On this pump, the most vacuum it pulls is about 26 inches of mercury. Alright, that is really close. We're going to try calling that good. Let's see how well we can hear our speaker or not with a vacuum. Here goes, playing the same clip of music.
Actually, here most of the air is sucked by the vacuum machine.
Oh, if I touch my ear to it, then I can hear a little tiny bit. It's extremely quiet. And I can't hear anything if it's on the glass. It's only on the plexiglass side where the speaker is actually pointed right at it. So there may be a tiny, tiny bit of air still in there, or maybe it's conducting directly through the speaker, into the cotton balls, into the glass, through the rubber to the plexiglass. I don't know. I'm letting it in slowly so we can kind of see at what point we can hear it. I'm hearing a little bit of it now.
You see, sound is increasing now. As the air goes in, sound is increasing. Okay guys, I think you have understood. If there is no medium, sound cannot be traveled. Now, light and similar waves are called electromagnetic waves, EM. An electromagnetic wave is disturbance in electric and magnetic field. We know that magnetic field is not depending on any material. Without any medium, also we are able to sense the magnetic field, as you have learned before. Sunlight is an example of electromagnetic waves. Other examples include radio waves, microwaves, and X-rays. Actually, electromagnetic waves has, great range of the lights, the great range of the waves. X-rays, ultraviolet waves, gamma rays, all of them are actually called electromagnetic waves. And we just know the visible light, right? We are able to see just that one. But rather than just visible light, we know the X-rays. We are able to see our bones with the X-rays, internal structures with the X-rays, right? Microwaves, for example, we are able to heat our food in that machine, in that tool. What do? We heat up it by using microwaves, goes through our food, and how much the crest of the waves hit our food, that much our food is heated up. Okay, you see, again, waves are actually traveling through our solid food, okay, or liquid whatsoever. But radio waves, for example, we are not able to see, but it exists. Definitely it goes through the air, through the space. Okay, it doesn't matter. They are able to go in the space and in the medium. In empty space, all EM waves travel at the same speed, called the speed of light. Actually, speed of light is the fastest in the space, yes. But how about in the solid? How about in the air? How about in the liquid? Definitely, the speed of light is decreased in the air. Okay? It has less speed in the air. How about in the water it decreases much more its speed in the water. Okay, how about in the glass? Definitely in the glass also it decreases its speed. If I ask you what is the highest speed of the light, where is the highest speed of the light, in which medium we can see it, in which place we can say we can see the speed of light in the maximum level, you have to say it in the space, right? Not in the solid, not in our hands, not in the air, not in the water, not in the glass, but in the space. Okay, I think you have enjoyed it. Okay, let's start the question. Actually, I wrote just one question here. Which of the following wave does not need a medium? Here, just one answer. You are able to see electromagnetic wave. I think you enjoy it. Have a nice day, guys.